and complete all tasks. Once the lab exercise is completed, remember to leave a feedback and let us know how it went. A few things to note. These are publicly accessible labs that anyone can access. So if you catch yourself logged out during a peak hour, please wait for some time and try again. Also, remember to not store any private or confidential data on these systems. Remember that this environment is for learning purposes only and is only alive for an hour, after which the lab is destroyed. So does all your work. But you may start over and access these labs as many times as you want until you feel confident. I will also post solutions to these lab quizzes, so if you run into issues, you may refer to those. That's it for now. Head over to the first challenge, and I will see you on the other side. We will now look at some of the other Docker run commands. At the end of this lecture, you will go through a hands-on quiz where you will practice working with these commands. We learned that we could use the docker run Redis command to run a container running a Redis service. In this case, the latest version of Redis, which happens to be 5.0.5 as of today. But what if we want to run another version of Redis, like for example, an older version, say 4.0? Then you specify the version separated by a colon. This is called a tag. In that case, Docker pulls an image of the 4.0 version of Redis and runs that. Also, notice that if you don't specify any tag as in the first command, Docker will consider the default tag to be latest. Latest is a tag associated to the latest version of that software, which is governed by the authors of that software. So as a user, how do you find information about these versions and what is the latest? At dockerhub.com, look up an image and you will find all the supported tags in its description. Each version of the software can have multiple short and long tags associated with it, as seen here. In this case, the version 5.0.5 also has the latest tag on it. Let's now look at inputs. I have a simple prompt application that, when run, asks for my name, and on entering my name, prints a welcome message. If I were to Dockerize this application and run it as a Docker container like this, it wouldn't wait for the prompt. It just prints whatever the application is supposed to print on standard out. That is because, by default, the Docker container does not listen to a standard input. Even though you're attached to its console, it is not able to read any input from you. It doesn't have a terminal to read inputs from. It runs in a non-interactive mode. If you'd like to provide your input, you must map the standard input of your host to the Docker container using the -i parameter. The -i parameter is for interactive mode, and when I input my name, it prints the expected output. But there is something still missing from this: the prompt. When we ran the app, at first, it asked us for our name. But when Dockerized, that prompt is missing, even though it seems to have accepted my input. That is because the application prompts on the terminal, and we have not attached to the container's terminal. For this, use the -t option as well. The -t stands for a pseudo terminal. So with the combination of -i and t, we're now attached to the terminal as well as in an interactive mode on the container.